Boys and girls, this is Mr. Manise here again with another super cool video. And in this video, I'm going to walk you through how to work each of the problems on the rational equations and word problems quiz review. My disclaimer, as always, I need you guys to work these problems on your own, and then and only then come to the video and iron out any misunderstandings. I don't want you just to work a problem and look at it for 5 seconds and say, oh, I don't know what to do, let me just go to the video, because that doesn't help you. Doesn't do any good, doesn't help you learn, help you grow. So I need you guys to kind of struggle through these problems, and if you exhausted all possibilities, then come to the video. But anyway, it is September 23rd, 2019. Georgia just had a fantastic win. Number 3 Georgia against number 7 Notre Dame. Georgia pulled out the victory, so congratulations to the Bulldogs. I'm a diehard Clemson fan, of course, and in a lot of my videos I have some kind of Clemson reference. So in this one, I have a little Clemson fidget spinner. So I am going to spin this and allow you guys to look at it for 10 seconds. If you don't want to do that, feel free to double click on the YouTube clip and fast forward 10 seconds ahead of time. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Congratulations. All right, let's jump on in here. So I'm going to zoom in a little bit for each of these problems. And actually, before I do that, before I start number 1, some of you guys are still confused or struggling with common denominator. If you're good to go on common denominator, I'm going to ask that you guys go ahead and fast forward about 5 minutes or so. It'll probably take me several minutes to explain this, and go ahead and just fast forward till you get to number 1. But those students that are still struggling with the concept of a common denominator, let's go back and address this. So if we go back and look at regular numbers, I did this in class, but I'll do it again. Let's say we had something like 5 over 8 plus 2 over 8. When I'm adding and subtracting fractions, when I have a common denominator, I just add across the top. If I have a scenario like this, let's say I had 3/4 plus that same 2 eighths. Now to get a common denominator, what I do is I'm going to look at the little number. I call it the little guy, big guy. Does the little guy divide evenly into the big guy? Does 8 divided by 4, does that come out to be a nice, pretty, clean answer? And the answer is yes. So the big guy is my common denominator. Well, how do I get 4 to an 8? I would need to multiply by 2 over 2, which is a big fat 1. And then I would have a denominator of 8. So I'd have 6 over 8 plus 2 over 8. And I could go ahead and add those together, and I could go ahead and simplify. So let's say we had this scenario. What if I had 5/4 plus, no, let's do something. Let's do, I don't know, let's do 5/6 plus 2 eighths. I'll keep that same 2 eighths concept. 5/6 plus 2 eighths. You might look at this and say, well, they don't really have anything common, so I'll just multiply them together and I get 48. So my least common multiple, or my common denominator, would be 48. And that's not correct, because we have something smaller, least common multiple. So when I'm trying to figure that out, I look at the big guy and I look at multiples of the big guy. So if I double this and get 16, does 6 go into 16? No, it doesn't. What if I triple this? 3 times 8 is 24. Does 6 go into 24? Yes, it does. So the common denominator, or least common multiple, is actually 24, something you guys learned in elementary school. So to get 24, this guy needs a 3 over 3, and that guy needs a 4 over 4. So I'd have 20 over 24 plus 6 over 24, and I get 26 over 24, and I can go on to simplify that fraction. All right, what if I have this scenario, 5 over 8 plus 3 over 5? Okay, there are no multiples of 8 that are divisible by 5 until I get to 40, which is just multiplying these two numbers together. So 5 times 8 is 40. So in this case, my common denominator is actually 40. So sometimes these don't have anything in common. You just have to multiply them together. So this guy, of course, would need a 5 over 5, and that would need 8 over 8. Okay. What if I have 3 terms, or 3 fractions? What if I have 2/4, all right, no, I'm going to change that. 3/4, let me start over. Let's start here. Let's go 1/2 plus 3/4 plus 7/8, something like that. Do these guys have anything in common? They do. So when you have multiple fractions, you look to see, does the little guy divide into the big guy, or the little guy divide into the medium guy, or the big guy, and you look to see, does the medium guy divide into the big guy. If they do, then you don't have to worry about that guy anymore. So does 2 go into 8? Yes, it does. Does 4 go into 8? Yes, it does. So I'm not really looking at those guys anymore. Every multiple of 8 will have multiples of 4 and 2. So my common denominator, that is, the big guy is my common denominator. So this guy would need a 4 over 4, and this guy would need a 2 over 2. Okay. Now what if I change this up? Let's keep the same fractions. 1/2 plus 3/4, but now instead of 7/8, let's change this to 7/11. Okay, now do they have anything in common? Well, neither 4 or 2 or 4 divide into 11, but the little guy goes into the medium guy. 2 goes into 4, so I don't care about the 2 anymore. Every multiple of 4 will have a multiple of 2. So really, I'm just looking at the common denominator between these two, because whatever is common between these two will also be common to 2. So now I just multiply them together. My common denominator would be 44. Okay, so what does this guy need? This guy needs a 22 over 22. This guy would need 11 over 11, and that guy would need a 4 over 4. And I would go from there. Now, we're going to take these same concepts and apply them to polynomial expressions. If I have something like 3x squared, say I had 4 over 3x squared, okay, plus 2x over, say, 6x to the 4th, something like that. That would obviously be the big guy, the biggest coefficient with the highest exponent on the variable. Does the little guy go into the big guy? To answer that, you can divide it out. Y'all should be able to just kind of visualize this in your head. Does the little guy go into the big guy? Yes, it does. 3x squared goes into 6x to the 4th, 2x to the 2nd times. Okay, so that's just 2, and 4 minus 2 is 2. Okay, what if I had something like 1 over x minus 5 plus 2x over x minus 5 squared? Well, I could separate this out, 1 over x minus 5 plus 2x over x minus 5 times another x minus 5. Does the little guy go into the big guy? X minus 5 times x minus 5 divided by x minus 5, does that come out to be something nice and pretty? It does, because they cancel. X minus 5 goes into x minus squared, x minus 5 times. So this guy is my common denominator, which would mean this guy needs one more x minus 5, so that I can both have an x minus 5 squared on the bottom. Think about this concept. 1/3 plus 2 over 9. You say, what's the common denominator? Common denominator is 9. 3 goes into 9. But couldn't I rewrite this as 1 over 3 plus 2 over 3 squared? 3 squared is still 9. I haven't changed anything really. So I've got a 3 and I've got a 3 squared. So what is the common denominator? I got one of these, I got 2 of these. So this is common to 3. So I don't really care about the 3 anymore. The common denominator is my 3 squared, or in this case we know it's 9. Okay, so let's just keep these thoughts and ideas fresh in our mind as we work through some of these problems. Okay, number 1, let's jump right on in. I'm going to zoom in a little bit. Okay, solve each and then check for extraneous solutions. Okay, so here I've got 3 different things. I got a 3x, a 3x squared, and a 6x squared. This will be the little guy. That would be the big guy. So does the little guy go into the big guy? Use my purple pen. Does the little guy, the 6x squared divided by 3x, does that come out evenly? Yes, it does. That goes into the big guy 2x times. So I don't really care about the 3x anymore. That doesn't come into the common denominator. What about the medium guy into the big guy? This 6x squared divided by 3x squared, does that go evenly? Yeah, that comes out to be 2. So I don't need the little guy. I don't need the medium guy. I just need I don't need the small guy, I don't need the medium guy. The big guy is my common denominator. Every multiple of 6x squared will contain multiples of 3x and multiples of 3x squared. So my common denominator is 6x squared. Okay, so let's spread this out. So the 2 over 3x squared, what does that need to get to 6x squared? That needs a 2 over 2. And then I have the 1 over 3x. What does that need to get to a 6x squared? That needs a 2x, and that's equal to 1 over the common denominator. So I don't need to do anything with that. That's already the common denominator. So now I just multiply across the top. I have 4 over 6x squared. plus 1 times 2x. That's 2x over 6x squared equals 1 over 6x squared. Once I have the common denominator, of course, I could multiply both sides of the equation by 6x squared, and they would all cancel out. I've already shown you guys that in class. So the way I've taught you is we can just cross out those common denominators that go away. And I'm left with a simple algebraic equation on top. 4 plus 2x equals 1. 2x equals negative 3. And x equals negative 3/2. Okay, I got to check my EVs. Check for state the excluded values. Check for extraneous solutions, all that good stuff. So my excluded value, I only have a monomial with a variable, so my excluded value is 0. That does not match my solution, so I do not have an extraneous solution. So I am good to go. Now let me show you guys, I'm going to check 2 of these on the graphing calculator, because I know some of you guys say, oh, always check it, it never comes out right, or you're not sure, or maybe you don't have enough time to check your answers. That means you need to work a little bit faster. If you're not willing to check your answers, then you're just going to have to deal with the fact that you're going to make careless mistakes and you're going to lose points if you're not willing and able to check your answer. Now, the trick that I taught you guys at the beginning of the polynomial unit is you plug in the original question, you plug in your answer, and make sure the numbers match. That's when you are simplifying stuff. And that applies to all kinds of stuff in math. I'm taking this form right here, and I'm saying that is equivalent to this form right here. Okay, now when you actually have an equation, we can't do that. I can't type this in and get a number because there's an equal sign there. So when you have an equation, you literally have to take your answer and plug it back in for x and make sure that the equation balances or holds true. Now, this answer is negative 3/2. I picked this one to check because it's a nasty fraction. Anytime you have something like this, guys, and you're plugging it in for x, don't plug in negative 3/2, okay, because you're going to have to double up on the parentheses because you've got a fraction. What I would do, and I'll zoom out here so y'all can see, what I would do on my calculator is I would convert whatever non-pretty number it is, just convert it to a decimal. Okay, so negative 3 divided by 2, of course we know is negative 1/2. And now I'm going to use the second answer feature. Down here, the negative button above that in blue is A&S, answer. So everywhere I see an X, instead of plugging in negative 3/2, I'm just going to say second answer. And that's a whole heck of a lot easier. I don't have to worry about parentheses. All right, so on top, I have 2. I don't need parentheses for that because there's just one number at the top. Now I do need parentheses in the bottom because there's a coefficient and a variable. Divided by 3, now instead of plugging in negative 3/2 squared, I'm just going to type in second answer squared. Second answer. All right, and then squared. I don't even need to press times because my calculator sees that as 3 times second answer squared plus 1 divided by parentheses 3 second answer, close the parentheses, and there's our equal sign, so I'll stop. Let's get a number. Okay, fine, whatever. We're saying that the left side of the equation is that. That should be equal to the right side of the equation. Okay, now you can plug the negative 1.5 back in and get a number if you want, so let's do that again. Negative 3 divided by 2, and then I'll just use the second answer feature. So we're saying that's equal to 1 divided by parentheses 6 second answer squared. Close the parentheses, and that better equal what we got up here, and the numbers match. Okay, so yes, please. I know it takes me a minute or so to explain that, but once you guys do a bunch of these, you'll be able to check these things in 20 seconds. You know, so you guys should be actually practicing checking these at home. Don't just sit there and say, oh, I'll check it on the test. Don't do that. You need to practice this now so that when you go to check, when you do that, then you're much more efficient. You're quicker. Okay, number 2. Zoom back in a little bit. Okay, I've got an n, a 2n, and a 2. So the 2n would be our big guy. Does the little guy, does 2 go into 2n? Yes, it does. It goes into it n times. Does the medium guy go into 2n? Yes, it does. It goes into it 2 times. So the big guy is our common denominator. Every multiple of 2n will have a multiple of 2 and a multiple of n. So common denominator is 2n. So n minus 5 over n, what does that guy need to get to 2n? It needs a 2 over 2. All right, that equals 1 over 2n. That doesn't need anything. That is our common denominator. Plus 3 over 2. What does that need to get to 2n? It needs an n over n. Okay, so I have 2n minus 10 over common denominator equals 1 over common denominator plus 3n over common denominator. Those go away, and I have a simple equation, 2n minus 10 equals 1 plus 3n. I always want a positive variable, so I'll subtract 2n from both sides. So I'll have an n over here, subtract 1 from the right. That'll be negative 11, negative 10 minus 1, negative 11. EV is just 0. That does not match our solution, so we're good to go. If you want to check that, just literally plug it back, negative 11 everywhere you see an n. Okay, number 3. Okay, guys, you must factor denominators. When you have binomials, trinomials, GCFs, you always want to factor stuff in the denominator. You do not need to factor the numerator. I do not need to pull out a 3 here, because in the numerator, we're going to have equations to solve. I don't need to factor out GCFs when I'm solving an algebraic equation, okay? I just need to combine like terms and solve for x. So here, I must pull out an x times x plus 1. And I'll do the same thing here. Pull out x times x plus 1. Okay, does x and x plus 1 have anything in common? Yes, so the least common multiple, the common denominator, is x times x plus 1. That's your common denominator. Okay, so 6 over x. What does that need to get to x times x plus 1? It needs an x plus 1 over x plus 1. The 1 over x squared plus x, that doesn't need anything, equals 3x plus 12 over x squared plus x. That doesn't need anything. All right, so these are our common, x times x plus 1 is x squared plus x. So our common denominators go away. So when I distribute, I have 6x plus 6 plus 1 equals 3x plus 12. So I have 6x plus 7 equals 3x plus 12. 3x equals 5 divided by 3. And x equals 5/3. Okay, EVs. Let's go back up to our factor form. I have an EV of 0 and an EV of negative 1. Okay, so we're good to go. Our solution is not an EV, so we do not have extraneous solutions. So there we go. All right, this is going to be the last one that I check because it's a nasty fraction. So once again, let's practice with this second answer business. Okay, so let's type in 5 divided by 3. And we're saying that's what that equals to. So let's go back up here. I've got 6 divided by second answer, no parentheses there, plus 1 divided by, I do need parentheses here, 1 divided by second answer squared plus second answer, close the parentheses, and there's the equal sign, so we'll stop. Okay, fine, 3.825. Now over here, let's get our second answer again. Let's do 5 divided by 3, okay? So I do need parentheses because there are 2 terms up here in the numerator. 3 second answer plus 12 divided by parentheses second answer squared plus second answer. Close the parentheses, and what do you know? 3.285, and they match. So that guarantees I've done this correctly. That didn't take me but 25 seconds or so, and that's me explaining it. Okay, let's try this one, number 4. Okay, I see a trinomial, so that means I definitely need to try to factor this guy. Okay, what are the factors of 10 that add a negative 7? That's negative 5 and negative 2, so p minus 5 minus minus, p minus 5, p minus 2. Same thing here. Okay, this is missing a p minus 5. So does p minus 2 go into p minus 5, p minus 2? Yes, it does. So this guy needs a what? This guy needs a p minus 5 over p minus 5. Okay, so I've got p plus 6 over, I'm just going to say common denominator, equals p plus 3 over common denominator, plus literally p minus 5 over common denominator. They all go away. P plus 6 equals p plus 3 plus p minus 5. You can combine the p's here, but I've got a, with addition, I've got a p on the left and a p on the right, so they drop out. So 6 equals p minus 2. Subtract 2 from both sides. I get p is 8. Okay, what are my EVs? If I go back up to my factor form, I've got an EV of 5 and an EV of 2. So we are good to go. No extraneous solutions. Okay, number 5. Okay, here's where students get tripped up a little bit. I've got an n and an n plus 6 and a nothing. Does n go into n plus 6? Okay, so does n plus 6 divide by n? And I still got students that are trying to do that mess right there and saying, yeah, that simplifies to 6. No, you can't cross out stuff in fractions, numerators, and denominators when you've got pluses and minuses in between the numbers and the terms. Okay, you can't do that. If you just plug in a number, let's just say n is 2, or let's just say n is 1. If n is 1 and you cross out the n's, you're saying that this simplifies to 6. But clearly that's not the case, because n is 1, you've got 1 plus 6 over 1. 6 is not the same thing as 7. So clearly that you can't do that. Okay, so there's nothing common between n plus 6 and n. So when there's nothing in common, you have to multiply the two things together. So my common denominator in this one is actually n times n plus 6. Okay, now when you have a number out here with no denominator where it needs everything, I'm perfectly okay if you guys just want to go ahead and distribute this out and say the common denominator is n squared plus 6n. That's perfectly fine. So the 5 over 1, what does it need? It needs this. So instead of writing 5 times n plus 6, I'm just going to write this. 5 times n squared plus 6n over n squared plus 6n. That is the common denominator if you just multiply this out. Minus 5 over n plus 6. So what does this guy need? This guy needs the n. So n over n equals 6n minus 12 over n. What does this guy need? It needs the n plus 6. Okay. So if I distribute here, I'm going to have 5n squared plus 30n minus 5n. This is over common denominator, common denominator. Now here you're going to have to FOIL this out. Binomial times a binomial. First, 6n squared outside, 36n inside, negative 12n, and last is negative 72 over the common denominator. Those go away. So now let's combine like terms. So on the left I've got 5n squared plus 25n. On the right, 36n minus 12n is 24n minus 72. Now I need to get everything to one side of the equation. So I've got a 5 on the left and a 6 on the right, which means I need to move the 5 to the other side. Let's subtract 5n from both sides. So I'll have n squared, all right, and we need to subtract 25n from both sides. So 24 minus 25 is minus 1, and then we have the minus 72 equals 0. What are the factors of negative 72 that add to negative 1? That's 9 and 8. The bigger one has to be negative, so this factors is n minus 9 times n plus 8. I'm going to flippy flip. So n is equal to 9 and negative 8. Let's check out our EVs. Going back up to the factored form here. I have the EV of 0 and an EV of negative 6. So we're good to go. No extraneous solutions. Okay. All right, number 6, let's increase the rigor here a little bit because you guys are the accelerated, gifted block math students and you can accomplish anything. That's the attitude you must have. All right, let's always factor our denominators first. Factors of 20 that add to 9 are 4 and 5. The 1 has nothing, and this guy has an a plus 4. So what is common between a plus 4 and a plus 4, a plus 5? A plus 4, a plus 5 is your common denominator because a plus 4 does divide into a plus 4, a plus 5. So common denominator is both of these. Now here, like I said, when you have just one number with no fraction, no denominator, you can go ahead and just FOIL this out, or in this case, you can just leave it like that. So the common denominator is a plus 4, a plus 5, or you can just leave it as a squared plus 9a plus 20. Okay, so this I'm just going to bring down. We leave this alone. I'm just going to write common denominator. Now what does the 1 need? The 1 needs everything. So it needs this whole common denominator. So a squared plus 9a plus 20 over a squared plus 9a plus 20, which is a big fat 1. I'm just going to leave it as common denominator. Now what does that guy need? This guy needs what? It needs an a plus 5 over a plus 5. So plus 2a times a plus 5. 5. Common denominators go away. So a minus 4 equals a squared plus 9a plus 20 plus 2a times a is 2a squared plus 10a. Just distributing there. All right, and now let's combine like terms. I've got a squared and an a. I'm going to move all of this to the other side. So a squared plus 2a squared is 3a squared. All right, and then I've got 9a plus 10a, that's 19a, and then I got to subtract a from the left, so 19 minus 1, that gives me 18a. And then I've got 20, I'm going to add 4 to both sides, 20 plus 4, 24. Now I've got everything to one side of the equation, so set equal to 0. Okay, what do I have to do to solve this quadratic? Oh, I got to do the rainbow thing, right? Always look to see, can you factor out a GCF? They're all divisible by 3. That will make your life a lot more, much better, easier. Happiness. Okay. Factor out of 3, a squared plus 6a plus 8. Now that's a heck of a lot easier to factor. Factors of 8 that add to 6, that's 4 and 2. a plus 4 times a plus 2. The 3 just drops out if you divide both sides by 3. So if I flippy flip, a equals negative 4 and negative 2. Okay, let's check out our EVs. I'll go back up here to the factor form. The EVs are negative 4 and negative 5. Uh-oh. One of my EVs matches one of my solutions. I cannot have that. So that is an extraneous solution. So what I need to see on your quizzes and tests is A equals, not what I just wrote, A equals negative 2. That is the only number that I can plug into this equation, and the left side equals the right side. Okay. All right. Oh boy, the word problems. I love word problems. I know you guys cringe at them, but you know what? I mean, I was an engineer, guys, for 10 years, and I've never had my boss come up to me and say, here's what I want you to do, buddy. I want you to do this worksheet. Number 1, number 2, number 3, I want you to solve for X. Guys, it doesn't work like that in the real world. The whole world revolves around word problems. Your boss is going to hand you a memo, send you an email. Somebody's going to verbally tell you the information you need. You got to take all the information back to your office or your cubicle, and you got to work through it and figure it out. The world works on word problems. All right, so here we go. This is one of those acid problems. How many milliliters of 20% acid must be added to 40 milliliters of 75% acid to create 30%? Guys, I would strongly suggest that on these water current problems, acid problems, draw yourself a little picture. Let's come out here to the side. And what in the heck is actually happening here? Okay, how many milliliters of 20% acid must be added? So this is what I'm adding. I'm adding it to 40 milliliters of 75% solution. So this is 75%. Okay, to that, I'm going to add how many milliliters must be added. I don't know what I'm adding. Okay, so that's 40 millimeters. This is X millimeters. How much of 20% acid, how much of the 20% do I have to literally pour into this vase to end up with a solution that is 30%? And the total volume will be X plus 40. The original plus whatever I add. Okay, so draw yourself a little picture. All right, I'm not, I wouldn't take all points if you guys didn't set up the little chart that I have shown you guys, but for me, it's just a good way to be organized. So let's set up our little table here, our little chart. All right, so I'm going to have I'm going to have amount of acid. I'm going to have total solution. I'm going to have my original. I'm going to have whatever I added. And then I'm going to have the final, which is the new. I'm embarrassed of that chart, by the way. I need a ruler. Okay, anyway, So the original, how much acid is in there? It's 75% of 40 milliliters. So 0.75 times 4, 3/4 of 4, which of course we know is 3. The total is the 40 milliliters. Okay, I'm adding, how much am I adding? We don't know, that's the unknown. How much do I add of the 20% solution? So the acid in that one is going to be 20%, 0.2 times whatever I add, 0.2x. When I get done, I should have given myself a little more room here in the chart. When I get done, I'm going to have the acid from the original, 0.75 times 4. I'll go ahead and write that as a 3. The acid from the original plus whatever I add plus the 0.2x. Okay, that's how much acid I have over the total solution, which will be the original 40 plus whatever I add, x plus 40. Okay, now I'm ready to say when I get done, we want this new solution, whatever this is, we want it to be equal to 30%. How do you write 30%? 0.6, 3 over 5. I'm going to write this as 30 over 100 just because we're used to seeing percentages out of 100. So now I can set up an equation. I can say all of this mess, all of this, 3 plus 0.2x, the amount of acid over the total solution, x plus 40, we want that to be equal to 30%, or 30 over 100. Okay, so the common denominator, there's nothing in common, so I have to multiply them together. Common denominator is 100 times x plus 40. Okay, so this guy needs a what? It needs 100 over 100. This guy needs the x plus 40 over x plus 40. Okay, so when I distribute here, I have 300 plus 0.2 is going to be 20x, of course, over the common denominator, and that's going to be equal to 30x. 30 times 40 is 1200 over the common denominator. Common denominators go away. Get my camera back in focus here. There we go. Okay, so I have 300 plus 20x equals 30x plus 1200. Okay, I want to keep a positive variable, so let's subtract 20x from both sides. So I have 10x. Let's make sure I do this correctly. Oh, I made a mistake, guys. I'm sorry. Y'all are probably screaming at the video right now. That's supposed to be a 30 instead of a, because it's 75% of 40 milliliters, which is 30 milliliters. So that should be a 30, which means that should be a 3,000. Okay, sorry about that. Okay, so 3,000 plus 20x plus 30x plus 1,200. So let's subtract 1,200 from both sides. That will leave me with 1,800 and divide by 10. And I get x is equal to 180 milliliters. Yeah, that should have been a 40 instead of a 4. Okay. So, does our answer make sense? We're starting out with 40 mils of 75%. I've got to get that 75 all the way down to a 30. That's going to take a lot. So, yeah, I buy that this is almost 4 times as much to take it from 25, adding 20%. I'm going to have to add a lot of that to bring it all the way down to 30%. So I buy that. That sounds reasonable to me. Okay. All right. So number 8 is one of those water problems. Instead of water and a current, we're talking about a bicycle and wind. It's the same concept. So Sarah's average speed riding her bike is 11.5 miles per hour. She takes a round trip of 40 miles. Please circle that. Please pay attention to that, because I know last year a lot of students miss points on quizzes and tests and assessments because they forget what round trip means. So if we want to come out here and draw ourselves a little picture, so here's the road, and let's say the wind is going this way. So Sarah, it says it takes her 1 hour and 20 minutes with the wind. So she's pedaling on her little bicycle. She's pedaling with the wind, 1 hour and 20 minutes, and then she turns around and it takes her 2 hours and 30 minutes riding back up against the wind. It says, what is the speed of the wind And she's taking a round trip. What does round trip mean? There and back. So if it's 40 miles for round trip, that means it's 20 miles going down and 20 miles heading back up. Okay, so don't miss points or miss the whole problem because you missed that concept. Okay. All right, so this is one of those time chart problems. So let's set up our chart. Time with the wind, time against the wind. Do we have a total time here? I want you to think about that for a second. I don't see that magical phrase in the same amount of time. Obviously, it's not the same amount of time because it's faster with the wind than it is against the wind. So I do have a total time here, but we have to figure that out. That's one reason these word problems, students always say, oh man, these are so hard. Yeah, because in real life, you have different variables, you have different things you're trying to find, you've got different ways, different little tweaks that you have to do to these problems. So we've got to figure out what is the total time. It takes her an hour and 20 minutes there with and 2 hours and 30 minutes back. So that's 3 hours and 50 minutes. So the total time is 3 hours and 50 minutes. Okay. Now the time with the wind, remember time is always distance over rate. Okay. And I want to make sure students are comfortable with this little concept here. When we're setting up these charts and you've got time with, without, whatever, you're always going to have the distance. In this case, the distance we said was 20 because it's a round trip. So she's going 20 miles down with the wind. And let's say we got 20. You're always going to have two things here, two little circles. You got something you got to put in there, something you got to put in there. The thing you put in this first little circle is always the still speed. What is my speed in still water? What is my speed riding the bicycle with no wind? What is the normal rate? And then you're going to add and subtract the rate of the current, the speed of the wind, you know, all that kind of stuff. Okay, so the regular normal rate plus or minus whatever the current wind is. All right, let me be clear on that. Okay, so the first one is her still speed, which is at 11.5 by herself, with or without wind. And that's going to be plus the rate of the wind, which we don't know. That's what we're trying to find. Time against the wind is going to be the same 20 miles back up, and it's going to be her normal speed minus the wind. She won't be traveling as fast. Now over here, the total time, guys, we can't leave this as hours and minutes because everything, the final answer needs to be in miles per hour. So what do I need to do here? I need to convert that to hours. How do I do that? Well, 50 minutes divided by 60 minutes is that much of an hour. Plus the, why did I write 5 there? It's been a long week. Yes, I know it's Monday. That's 3. 1 hour plus 2 hours is 3 hours and the 50 minutes. Okay. So 50 minutes is 0.83% of an hour. So 0.83 plus the other 3 hours, that's how long it takes. 3 hours and 50 minutes is 3.83 hours. So I'm going to put parentheses 3.83 hours. Okay, now everything is in hours. Now we're good to go. Okay, so the time it takes with the wind plus the time against the wind equals the 3.83 hours. So our common denominator, of course, is that and that. 11.5 plus R times 11.5 minus R. Normally I would say the math is easy. This math is a little bit intensive, so let's just take this slow. Okay, so I'm going to start with the first thing over here. I've got 20 over 11.5 plus R. Now what does this guy need for the common denominator? This guy needs the 11.5 minus R over 11.5 minus R. All right, then plus against the wind, 11.5 minus 11.5 minus R. So this guy needs the 11.5 plus R. Okay, that is going to be equal to 3.83. But this also needs the common denominator. Okay, now the common denominator, 11.5 plus R times 11.5 minus R. Remember, this is a difference of squares. So you square the first term, square the back term, throw a minus in the middle. 11.5 squared, 132.25. So this is 132.25 minus r squared. So this needs the common denominator, which is 132.25 minus r squared over 132.25 minus r squared. Okay, so now our common denominators all strike out. So when I distribute here, 20 times 11.5, what is that? Okay, 230. And then 20 times negative r minus 20r. 20 times 11.5 is another 230 plus 20r equals 3.83 times 132.5, 0.25 times 3.83 is 506.5. I'm going to round that to 507, and that's okay because we're just trying to get an estimate. We're not trying to get to the nearest hundredth place, okay? Is the wind 24 miles an hour? Is it 5 miles an hour? That's what we're trying to find. Okay, distribute here, that's 507, and then 3.83 times negative r squared is minus 3.83 r squared. Okay, negative 20r, they both cancel. So I have 460 is equal to 507 minus 3.83 r squared. Okay, so how do I solve that quadratic? How do I do it? Well, I don't have an r term. I don't have that quote-unquote, that b term. So when I don't have the middle term, that square root method all day long. I just need to get r squared by itself and take the square root. So I've got a negative r squared, so I want to move that to the other side. So we've got positive 3.83 r squared, which means I need to subtract 460 from the left. 507 minus 460 equals 47. Divide both sides by 3.83. R squared is equal to, call that 12.3. Take the square root, and technically I generate square root of second answer. Technically it's plus or minus 3.5, but of course we can't have a negative, the wind's not blowing at a negative mile an hour. So the wind is blowing at approximately 3.5 miles per hour. Does that sound reasonable? Yeah, I mean that's not very much wind. So you might say, well shoot, that's a big difference in time for such little wind. I mean, it doesn't seem like the wind would make that much effect. If it's only blowing 4 miles an hour, that's not really going to change much, is it? But remember, she's doing this over 20 miles, okay? Traveling against the wind for 20 miles? Oh, okay, yeah. So again, ask yourself, does my answer make sense? Okay, thank you, sweet Jesus. We finally get to the easy one. Okay, Mike and Tom wax cars. Cool. Mike can wax in 60 minutes. Tom can wax the same car in 80 minutes. How long will it take working together? So we have our classic equation, 1 over A plus 1 over B equals 1 over T. Doesn't matter which one A and B are. 1 over 60 plus 1 over 80 equals 1 over T. There's no need to convert this to hours because it just says how long will it take. So no conversion here. What is my common denominator? Okay, when I see something like this, imagine that the zeros aren't there. What's the common denominator of 6 and 8? I just did this before the video. We said that was 24, right? And then I have the t, so my common denominator is 24, but there's a 0 there. So it's 240t, which means the 1 over 60 needs a what? That needs a 4t over 4t. The 1 over 80 needs a 3t over 3t. And the 1 over t needs a 240 over 240. Okay, common denominators scratch out. So I have 4t plus 3t equals 240. So 7t equals 240. Divide by 7. And t is approximately 34.3 minutes. You know, again, real world, 34 minutes. I would not go back to my boss and say, boss, it's going to take us 34.3 minutes. Okay, I'll just say it's going to take it. In fact, in the real world, I'll probably say, close to a little over 30 minutes. Okay. So does that make sense? 34 minutes. Well, if you average these two together, 1680, that's 70, and divide by 2 for 2 people, that'd be 35 minutes. Remember, we said that this answer is going to be a little bit less than the average of the times divided by 2 because one of them is working faster. And since there's not much of a difference between 60 and 80, I would expect this value to be pretty close to the average of the times divided by 2. So that's a good little gut check for you. All right, that's it for this video. And hope you enjoyed that. Hope you are studying hard because this stuff is really, really hard. We're right in the midst of the hardest stuff we do. So need you guys to buckle down and let me know. Come here in the morning if you got any questions right before the quiz, and we'll go from there. Thanks for watching this video. We will see you on the next one.